Hey, Jake Theliber here, Safety Application Engineer out of Minneapolis, Minnesota. Regret to inform you guys that my schedules didn't align for this monthly live safety webinar with Russ and myself, but I am coming to you recorded live from my hotel room as I travel, and I still wanted to give you guys some time to talk about our safety interlocks. I wanted to go ahead and start demystifying, debugging some misconceptions about coding levels, and then also be defining the 4 types of safety interlocks for you. And then you'll be in good hands with Russ for the rest of it. He'll be talking about some of our RFID-based switches and some of the benefits. So let's go ahead and jump over to presentation mode. I will try not to take too long for you guys. But first thing, before we get into some of the standard stuff, let's talk about the culture of workplace, because ISO 14119 is pretty closely related to some of these concepts that actually most of us, if not all of us, have seen firsthand is defeating of safety devices, commonly defeating of safety interlocks, right? So yeah, the two are kind of notoriously linked to one another. This is important for manufacturers of the device, so we want to make the devices user-friendly for you, so we prevent the motivation for defeating. It's important for integrators because applying the device correctly within the recommendations of the standard will also contribute to a safer workplace, and then also just education for end users of this equipment so that they understand how the devices should be used, so on and so forth. So let's just walk through the cycle here. Maybe on the day that this is implemented, hopefully we have a safe, correct behavior, and there should be no accidents if we're using it correctly. But the common perception is that added safety is a slower working speed, slower throughput, and eventually there's pressure. We need to have a higher throughput, less downtime, so on and so forth. This is generally a bad feeling, and operators say, how can we look for ways to increase throughput, make our jobs easier? Oftentimes, we forget about these safe, correct actions, and we start moving towards dangerous behavior, cutting corners, and maybe that's okay for a while. We have no accidents, and the throughput increases. This is a good feeling, and this is added motivation to continue this wrong behavior until eventually we get an accident. Then nobody's happy, and hopefully it's not a fatal accident. Try to prevent it. In the long run, we try to prevent this culture at the workplace to begin with. And like I said, the standards are very closely tied to some of these mindsets that this vicious cycle is showing here. So let's get into the definitions of these interlocks, and the definitions will help us understand, why we're choosing each type of interlock, how it relates to, which one I should choose for my application so that it's the best one to prevent some of that vicious cycle we talked about. So type 1 and type 2 are going to be mechanical-based actuation, and the type 1 interlock would be uncoded. Type 2, mechanical with coded. So in this picture, you might be wondering why is that one considered coded? Well, that tongue style key is a specific shape, and only that specific shape can actuate the interlock. So we haven't gotten into low, medium, high level coding yet, but in general, this is a specific shape. It's not easily repeatable. Only that actuator can actuate the interlock. That would be considered coded. So then type 3 interlocks would be moving away from mechanical actuation style and going to a non-contact type. And in this example, a safety proximity switch, that the actuation, the mode of actuation is basically any metal surface, that would be considered uncoded. It's repeatable. It doesn't take a specific actuator to switch the device. Uncoded with a non-contact type 3 interlock. Type 4 interlocks would be just following the pattern there, non-contact and coded. So this would be, for example, our RFID-based STR1 switch. So now that we kind of understand, what are the definitions, but we break it down into mechanical, non-contact, coded, and uncoded. And that's how we get 4 different types. So why is this important? How can this help me in understanding which switch I should choose? And we'll just go column by column here. First column is all the principles and measures that you need to consider. Some are mandatory, others are recommended. This is the list of measures. And then if we go to the next column, this would consider type 1 and 3 interlocks. And type 1 would exclude hinge type. We'll get to that in the next column, but if you're using type 1 and 3, you have to consider applying at least one of these first 5 measures. So mounting out of reach, physical obstructions or shielding of the interlock, mounting in a hidden position, status monitoring or cyclic testing, this would be done by the control, non-detachable fixing of position switch and actuator. So we must apply at least one of these if we're using a type 1 or 3 interlock. And then also, it's recommended to add an additional interlocking device and implement checking for plausibility, also done mainly by the PLC control system. And then just slightly differently, if we're doing a hinged device, so this would be a type 1 interlock, we must, mandatory according to ISO 14119, we must apply non-detachable fixing of the switch and actuator. So then we move into type 2 and 4, and this is actually broken down into medium and low level coding. So we can talk a little bit about what that means, but it's just the number of variations possible for that actuator. And I don't think we'll go into too far in detail on the definitions of the low and medium versus high level coding, but just know there's the number of different variations that can actuate it, and it must inherently be less than the uncoded. But again, permanently coded switch where it's only 1-to-1, of course that would be considered a high level coding. So 2 and 4 with lower medium coding, you must apply at least one of these, mount out at reach, use physical obstruction, mount in a hidden position, or do status monitoring or cyclic testing. Then you also must fix the actuator, recommended to add a secondary device, and check for plausibility. Type 2 and 4 with high level coding, so you'll notice this one is the least amount of restrictions when you're applying this device. You must apply a non-detachable fixing of the actuator. When we're looking for patterns here, how do we apply this device? Which one should I choose? Obviously, we notice most of these would recommend or actually consider mandatory per the international standard that you must fix the actuator. So what does this mean? This just means it's really good practice to use safety screws. That's how we would apply and comply with that section of the standard. Then what is the second trend that we see? Obviously we're seeing a bunch of recommendations, mandatory, check boxes, and in several of these. Then we get to the last column and we see that this is the least amount of restrictions when applying this device. So least requirements equals obviously the easiest installation. When you're using a high level coding device, example being our TR110 switch or our STR1 switch, where we can code to the actuators and have a higher level of coding, so the least amount of variations per the standard, we have the least amount of restrictions. So what this means is we don't have to consider mounting this out of reach. We don't have to consider shielding the interlock so that nobody can access it. We don't have to mount in a hidden position. We don't have to use PLC cyclic testing. Really the only requirement is to, again, use good practice of safety screws. So that is the really shorthand version of demystifying these coding levels. Why would I want to use it versus why would I not want to use it, and how do I apply it? So how does this actually affect me when maybe I'm applying this to a door?